Houston, the Mars Climate Orbiter is making its final approach of Mars. Increased thrust to 2 million pounds of thrust. Are you sure, Houston? That seems a bit off. Positive. Roger that. Oops.
Conversion's off? Sounds like someone didn't understand the gravity of the situation. Hello everyone and welcome to H2comb0, where learning from other people's mistakes makes you feel like a better person. I mean, come on, NASA. You lost $125 million just because you input data in English instead of metric units? You're NASA! You guys live around the metric system. Even Disney would never make that mistake. Seriously? A roller coaster derailed because the axles were in English units? Come on! Look, I don't mean to go off the rails here, but if you're going to science, then you're going to need to know the basic principles of how the metric system works. Now, I know what some of you are thinking. I ain't converting to no metric system. That ain't my tradition for America. Well, first off, you don't have to worry about that happening anytime soon in America. The cost of converting everything, including road signs, into metric would cost billions, maybe even trillions of dollars. Ain't nobody got time for that. Second off, this video is not about arguing that the metric system needs to be implemented or why it would be easier. It's about educating you on how and why we use it, so that you don't get fired or accidentally kill anyone because you forgot to move the decimal place. More on that later. First off, before we dive into the title of this video, we need to analyze what makes these two systems different. Have you ever wondered why a yard is not equal to a meter? I mean, what are each of these systems based on? To answer that, we will have to go back in time. Before the 1600s, each country in Europe used its own unit of measurement. As trade began to flourish, they started to realize they needed a common system to make things fair. Around the 1800s, England and France had the two dominant systems of measurement. England had the English system, aka imperial system, while France had the metric. Keep in mind, at this point, America was colonized by the English system. It wasn't until the early 1900s that England began changing to the metric system. Basically, this is the reason why America still uses the English system today. So back to the original point. What are these systems based on? Well, let's take a look at distance, in which this case, the English system uses foot, and the metric system uses meter. 12 inches equal a foot, and 1,000 millimeters equal 1 meter. What do you notice the difference between these two ratios? How about we add in mass? How about volume? How about now? Okay, let's remove the units. Do you see it now? That's right. The ratios on the metric side are constant, while the English side varies. The reason for this is the metric system is based on powers of 10. Why 10? Well, it makes sense, doesn't it, to make a counting system based around the number of fingers? It's one of the reasons why the Roman calendars pre-Julius Caesar went up to 10 months. Using a measuring system based on powers of 10 makes measuring so much easier because the values are constant. 1 kilogram will always be equal to 1,000 grams. 1,000 milliliters will always be equal to 1 liter, and 1 meter will always be equal to 100 centimeters. We use the prefixes to stand for how many multiples of 10 we need. This is extremely useful for measuring large and tiny numbers. And in chemistry, we do tiny, y'all, all the way to pico. And I don't mean pico de gallo. Hehe, now I'm hungry. Focus! Literally, it becomes more complex the bigger or smaller the units are in the English system. I'm sorry, but when you lay the evidence side by side, it's kind of hard to argue that the math would be easier with the metric system. I'll give you an example. Which one would be quicker to figure out in your head? How many miles are there in 5,000 feet, or how many kilometers are there in 5,000 meters? Here are the ratios in case you forgot them. Go ahead, I'll give you 5 seconds. Are you done? I bet most of you tried doing the math in your head with the feet to miles, but then said, let me get a calculator. But with the meters to kilometers, you only had to move the decimal. What makes the metric system even cooler is that it goes hand in hand with scientific notation. What if I asked you, what is the numerical difference between the following? The answer is, there isn't one. In fact, each of these are set equal to one another. The last one you were looking at is what nanometers would look like in scientific notation. Scientists use this method to save space instead of writing out all the numbers that are present while still preserving value, especially since we measure every little thing in chemistry. It's really easy to do, and you could probably tell your calculator to put your answers in scientific notation for you. Let's say I want to turn this 1 trillion nanometers into scientific notation. I just move the decimal until there's one whole number in front of the decimal and add times 10 to the end. I count how many times I moved my decimal to the left, and I put that as my exponent. If I move the decimal to the right, then my exponent would be negative. I round off to 2 decimal places, preserving value. Word of advice, kids. Never round to a whole number in chemistry. Unless specifically told to do so by your teacher. In that case, you might want to question every little thing they say. So I know a lot of you are probably asking yourself, can I convert between the English and metric system? And the answer is, yes! Of course you can! A lot of the math in chemistry is really mostly converting. Hence is another reason you should probably follow along with your calculator. Nerd. So buck up, chum. Let me show you how to manipulate matter to your will. So I'm about 6 foot 2 inches tall, which is 74 inches in total. By the way, always write your units in chemistry. Units are like clothing for numbers. When you don't write them, you have a bunch of naked numbers running around streaking all over your paper. And the last thing you need is to be committed to a mental hospital because you can't stop writing pornographic numbers all over your paper. Seriously, don't forget your units. Let's say I want to know my height in centimeters. In order to do that, I need to know the ratio between the 2 units that I need to convert between, which is 2.54 centimeters for every inch. In order to ensure high accuracy, we need to set this conversion up by using dimensional analysis. Really, it's just a fancy way of setting up fractions to cancel out units. It's incredibly simple as long as you follow these 2 rules. Number 1, ratios that are equal to each other can be flipped as you see fit. So you could say 2.54 centimeters over 1 inch or 1 inch over 2.54 centimeters. Number 2, in order to cancel out units, they must be diagonal from each other in order to cancel out. The rest is you multiplying fractions together to get your final answer. So if I begin with 74 inches over 1, then my only ratio that I can plug in to cancel out the inches is 2.54 centimeters over 1 inch. The inches will cancel out, and when I multiply the 2 fractions together, I end up with 187.96 centimeters, or in scientific notation, 1.88 times 10 to the second power centimeters. Wow, suddenly I seem a lot taller in the metric system. What are you gonna do when these 40-centimeter pythons wrap all around you? That's like 16 inches. I really need to work out more. Speaking of working out, if I lost 10 pounds in 18 days, how many grams per second was I burning? Well, for every pound, there are 454 grams. We placed the 454 grams over 1 pound. To figure out the seconds, we'll need to multiply the ratios to get the seconds. First off, we know that there are 24 hours in one day. We placed the days over the 24 hours. There are 60 minutes for every hour, so we placed a 1 hour over 60 minutes, and 60 seconds for every minute, so we placed the minutes over the seconds. When we multiply the fractions by one another, we get 0.002919238 or 2.919238683 times 10 to the negative 3rd grams per second. Whew, that's a lot. We round to 2 sig figs so we can conserve value for our answer, and we get 2.9 times 10 to the negative 3rd grams per second. Now you're probably asking yourself, why is he talking about figs? Are figs related to fig Newtons? Are fig Newtons named after Isaac Newton? No. Sig fig stands for significant figures. In other words, numbers that contain value. If we round too early, then we lose value. If we round too late, then we're writing too much. So we use sig figs to preserve value and conserve space. The rules are different when multiplying and adding. When multiplying, we round to the lowest number of sig figs based on the value given in the beginning of the problem. My problem began with 10.0 pounds over 18 days. The 10.0 has 3 sig figs, while 18 has 2 sig figs. Since the lowest number of sig figs is 2, I round my answer to the same number of sig figs. When adding, however, we take the lowest number of decimal places. For example, if I lost 5.85 more pounds, then I would add 10.0 to 5.85, giving me 15.85. I round to 15.9 because 10.0 had the lowest number of decimal places. I know the math seems like a foreign language, but with plenty of practice, you'll be a master chemist in no time. Just remember, you are in control when converting. Don't let the numbers do anything you don't want them to do. And also, write your units. Thank you all for watching. In this video, if you paid close attention, you learned the differences between the English and metric system and how to convert between them using dimensional analysis, the purpose of using scientific notation, and rounding with significant figures. If you have any questions or notice anything we missed, then post them in the comments below. Chem Quickies is written, produced, and edited by H2comb0 Productions. If you'd like to help with making more videos, then please visit our Patreon page by clicking on the link below. Hey, before you go, just wanted to say I love making these videos. They take a lot of time and energy to produce. Each video literally takes me over 200 hours. Seriously. So I just wanted to say thank you. Really, your continued support helps motivate me to produce better content. To show my appreciation, I just wanted to offer you a 30-day free trial on audible.com. You can now listen to all those books and news articles while you're on the go, for free. Just click on the link in the description below to start your 30-day free trial. And hey, if you're looking for books to help you out with your chemistry classes, might I recommend Chemistry as a Second Language by David Klein. Being a teacher myself, I've read these books and recommend them to all my students. Whether it's general or organic chemistry, they got you covered. They cover the topics really well, and you can find them on Amazon by clicking on the link below.